So, looking at the calendar, remember today is we're going to go over Volley. Hopefully, you've had a chance to read over the reading assignment. I will be skimming over just a little bit of that. There's a lot more in that reading assignment than I will be covering in the lecture today. So if you haven't completed that reading assignment, please make sure that you do. I'm also going to be pulling some questions that were asked on Perusal, and you'll see those on the slides. So we can kind of discuss a few things that were mentioned. People had questions on the reading assignment. I also mentioned that there will be a quiz later today, so do be prepared for that. Take notes as you need to, but yeah, just a heads up on that. Okay. Okay, so plan for today, we're going to go over Volley. I'm going to kind of do my lecture over that today. Tomorrow we'll have a lab over the stuff that we're covering today. Also tomorrow I need to try and catch up with everybody on work ethic progress. We're a little bit behind on that, but I need to try and meet with everybody if I can. Friday I will be out on vacation, so just a reminder, Evan will be here instead, substituting. So, any kind of burning questions before we get started? Just related to where we're at in the course and where we're going and scheduling.
I just got one question.
Mm-hmm.
Just overview Volley. What does this do exactly that the worker doesn't do? I'm not getting that. I know it keeps the thread clean and parses and stuff, but I'm not getting the value added.
Yeah. This does not replace the workers. This does not replace work manager or workers at all. Those are a separate sort of need. So what do workers do, right? Workers lets you do stuff in the background, specifically when your app is not running, and helps optimize it so it runs when there's network connection or other constraints are met, or allows you to do periodic work. Every 15 minutes, every hour, once a day, all those kind of things. Volley does not replace any of that. Okay. So Volley is not a replacement for work manager workers at all. What it is a replacement for is, I'll talk about this on one of the slides, is two things: async task and HTTP URL connection. So we'll still be using workers, and one of the things I'll go over here that wasn't on that reading assignment is how do you use Work Manager together with Volley, because as it turns out that's something important and it's not in their documentation. So I did actually write a lesson about how to do that, and that is now posted on Perusal. You can look at that later this week, but I will kind of cover how to do that and do an example with that here as well. So getting into it, so today we're talking about Volley, as I've kind of have mentioned and as you started to read up on. The main objective of this is that we're going to use Volley to make HTTP requests. That's really the whole goal here, is we want to use it to make HTTP requests. Previously, we've been doing that with the HTTP URL connection class. You remember we opened that up with URL dot open connection, I think it was, open connection. So you started with the URL, you open the connection. Well, Volley is kind of a wrapper around that. So the URL connection class is still inside of there, but we don't access it directly, which also means that we can get rid of a lot of boilerplate code. So kind of, I've talked about some of this stuff already, but kind of what is Volley? So Volley was created and maintained by Google. So it's actually a Google-owned library. It's not part of the core Android libraries. It is still considered a third-party library, but it is one thing that Google has created and maintained, and the official documentation for it is still on the Google training pages. Those training pages are a little bit out of date, and that's part of why the reading assignment that I've given you is an updated version of the documentation that I have created myself, because there's a number of things that we need to kind of point you in a different direction than maybe what's in the official documentation.
Hey, Mr. Smith.
Yep.
Are you only sharing Google, or are you on the slides right now?
I should be on the slides.
Because we're seeing the calendar right now.
Okay. Let me fix that. I must have clicked the wrong button. Change windows, screens. Okay. Can you see my slides now?
Yeah.
Okay. Yeah. So, created by Google, they're maintaining it. The big thing that it requires less boilerplate than the combination of async task and HTTP URL connection, which is really what it was created to replace, is those two things, async task and HTTP URL connection. Because it turns out, that's, hey, I want to go make a request, go get some data from the internet. There's a lot of code, repetitive code that you end up writing that really is the same almost every time you do it. So, creating a new async task, there's a lot of boilerplate in creating that. There's also just a lot of boilerplate in terms of okay, I have to create the URL, spawn up the URL connection, and then from there, set headers and do the connection, look at the status result. Is it 200 okay? Is it 404? Is it something else? How do I handle that? Also just a matter of, then I also need to create those streams, right? So we created you remember we had those series of streams. We opened the input stream, and then we wrapped a buffered stream around, I think we wrapped a stream reader. We created a stream reader around that, and a buffered reader around that. So there's a lot of stuff that we had to do to just get set up and make anything work and get data from there, right? So you're looking at the basic example of just saying, hey, I just want to get a little bit of JSON from the internet. You can write 300 lines of code just trying to do something what should be very simple to go do that, right? And it ends up being a lot of redundant and repetitive code. And because redundant and repetitive, we kind of call that boilerplate, right? It's boilerplate. You just copy. Boilerplate code is just code you copy and paste from project to project per project. Every time you do it, you just need to do these things. So async task, the whole point of Volley is to remove a lot of that boilerplate. So you can focus on just the things that are unique to your specific application, and not so much focus on repeating those details, which means you can focus on some of the higher up, more complex and the more business logic, which is where you actually want to be. It does also provide a little bit of caching and other performance improvements over what we have done with async task and HTTP URL connection. So for instance, the way we had set things up, every time we issue a request, we always go do a new request from scratch. So the caching that's built in there can say, oh, okay, well, we already did this request, 5 minutes ago, and we got this response. So let's just reuse that response rather than going and contacting the server again. It also actually, I said it replaced async task. It actually technically runs on executors in the back end, which is a whole nother topic as well. So there's a lot of things there and reasons why you want to use that overusing maybe the async task and the HTTP URL connection classes directly. The latest version that's out there is 1.20. So that's what we will be using in these examples. So to kind of do a little catch up and rewind and review a few things, I do want to show a little bit of this video. I posted it on Perusal. It's really about 2.5 hours long. I'm not going to watch all of it. I'm not going to play all of it because I don't really think that all of it is useful. But the first 14 minutes or so, he kind of does a good overview of, what is asynchronous, what are these asynchronous requests, what does it mean to connect to the internet, and I think that is valuable. So I'm going to play that part here because I think that's a good preface to, where we're at, where we're going with, the technologies that we've already talked about, what we talked about before spring break and Volley as well as retrofit, which we'll be talking about next week. So, pardon me while I switch this over. And I need to switch my screen again. So maybe switching back to the browser. All right, can everybody see the browser page now?
Yeah.
Okay. And then if you can't hear any sound once this gets going, just let me know and we'll try and troubleshoot it.
So first of all, what do we care about? Hi, in this video we're going to talk about network data and how it works in Android, and then I'll prepare you for a tutorial that's to follow. So there are 3 things that we're going to examine in this video. We're going to talk about what a REST API is, then we're going to talk about how to program what's called asynchronous code, and then finally we'll talk about the Volley library. So REST API is a term that you'll see in programming languages everywhere. It's really about clients and servers. The API stands for something called an Application Program Interface. And really in plain English, it means that there's a server somewhere that's providing data to the client. So that way you have either phones, computers, or watches, or something out there that is relying on a service on the internet. In the following videos, we're going to create a tutorial in Android using a REST API from the service called metaweather.com. And so we're going to have a service that looks like this, where it provides you with a weekly forecast. And it will be up to us to design the user interface so that that data comes out and looks good. So a REST API is a service that lets you look at specific URLs, such as the address that you see listed here. And instead of responding with an HTML page, a web page, you get back a pure data form. So it looks something like this here, where it says London, city, and an ID number. So REST APIs and microservices are 2 terms that often appear together. So sometimes a development team will break up an application into pieces, into micro pieces, you might say, and they use APIs to talk between those pieces. So a server can usually be split up into tasks. So this is a traditional model you might see. So we have at the bottom, we have a database, we have a data interface, we have a business logic, and then the user interface, a multi-tiered approach. Well, in microservices, you might say, well, that one data interface is actually could be split up into multiple pieces, and we'll call them microservices. Microservices can talk directly to the user interface, or they might provide data to other microservices. So that way you can have a modular approach to building your program. The link between those is the API. So the text messages that are traded between clients and servers are usually done in 2 different languages. One is JSON and the other is XML. There are others, but those are the 2 most common. So this is what Json Data looks like. You can see that this is a weather report. And you can also see that it is very easily understood when you look at it. It tells you what the ID number is, the type of weather that's for the day. You can see the minimum temperatures, the maximums. It's pretty much readable as a human would be able to see it. But you can also see that there are specific quotations and colons, and so it's a very data delimited piece of text. Now, the same data could have been created in an XML format. And so the XML format looks a little bit like you'd expect a web page. It's a hypertext. It's got these brackets and an open and enclose tag. And so they're not exactly doing the exact same process. XML has a little bit more functions to it. And it's not as popular either. So most people are working on the left side here with JSON data in their APIs. So JSON stands for JavaScript Object Notation. And it can be configured to send messages in not just JSON formats. APIs can be in others. But usually JSON is the type of data that you would expect to see. It's really common. And despite its name, JSON is not limited to JavaScript. So JSON can be used in many different programming languages. So if REST is associated with JSON, then the terminology SOAP is usually associated with XML. So SOAP stands for Simple Object Access Protocol. It's very similar to REST, but you can only see XML data when it comes to SOAP. So you could see JSON being used with REST and XML being used with SOAP, but they're both pretty much producing the same results here. They're both trying to communicate text messages to a client. So let's talk a minute about the client and the server. So the client's job is usually the one that says, I will initiate the request. I will ask for some data, and the results will be sent back into the format that the client can understand. So we're going to follow this video with a tutorial that will show you how to use the client for Android. So your client could be a phone, it could be a desktop, it could be a watch, it could be another server, but the client and server is just kind of a generic way to think about it. So that we will use a phone here in our example, but in other cases we could just as easily have programmed this as a web page. So what does an API look like? So the REST service usually has some kind of an endpoint that provides access to the client. So in this example, we have a URL from the website metaweather.com API location and then a location number. And then what follows from that is the weather report for that specific ID number, which happens to be the City of London. And so in a traditional web page, you would, at the green part of the stack of items, you would have said, this is the web page. In a REST service, we would say the URL endpoint is not a web page, it's just pure text, and then the client is responsible to format that text into the proper user interface. So how much work does it take to create a backend? Does it have to be written in Android? Does it have to be written in Java? What's the language? Well, the truth is, it doesn't matter what the language is. And server applications can be written in PHP, C#, they could be written in Java, Node, they could be written in Ruby, Python, pretty much any language that can create text files and communicate with a network is going to be eligible to make REST services.
What you're saying? What's on, you said the video's not showing anymore?
Yeah, the video tabbed out or something. It's showing now.
Okay. I don't know if I clicked something accidentally.
Is going to be eligible to make REST services. So the middle part here in the business logic can be any language that you choose. It's pretty much irrelevant. And so your teams sometimes are split up as a back-end developer and a front-end developer, and that's thanks to the ability to create these APIs that can bridge the gap between the front and the back end. Now, since there is such a nice standard with JSON, you can format the data to be output no matter what language that you're working with. And so we have no idea what metaweather.com used as their back end, whether it was Java, C# or something else. Now think about the amount of effort. So the UI, or the user interface in the front end, approximately takes about half of the amount of effort that it would take in the back end. Of course, that's determined by the complexity of your application. Sometimes the back end is really the secret sauce of an app, and that's what would take the majority of the time. So if you're interested in learning how to create the back end, I have other tutorials, classes on PHP, classes on Java, classes on C#, and all of those using their frameworks and their full stack will allow you to see how to create the database and then the URLs that are providing these services to you. But for the sake of it's going to follow here, we're going to create an Android application that is going to use a pre-existing free open source API. So we will only do half the work really for this weather app. Another feature that you're going to see in this application tutorial is that there is the idea of asynchronous code. Now, in most examples of coding, you're probably used to seeing synchronous code. That means one line follows the other. You can trace through exactly the order of statements in a program. However, with callbacks or asynchronous code, we have an external process going on. And that's why in network programming here, the idea of asynchronous or callbacks is going to be super important. So let's take an example here. So I have some code in this gray box, and its function says, get me some data. And it says, I want to go to a website, a URL, an API, let's say, and I want to get some user data. So it looks like we're looking for user number 99. Now, that's going to take some time because of the network traffic, and it's kind of could be on the other side of the world. It might take a couple of seconds for that response to happen. And so we're not going to sit around and wait for it. We're going to jump right into the next item in the program. So we're going to continue running. That's the synchronous mode. And we're going to just forget about our network request and let him catch up later. Now, that catch up later process is called the callback. And so when the process is done, there will be an alert sent to your application that says, hey, data's arrived, and what do you want to do with it? So the callback function will have a parameter, like a list or some kind of a string or something, and that will say, hey, I got the data back from the server, and now in this this red processing box here, you can go ahead and process that data. It means you can save it to the database or display it to the user or whatever your choice is. But the callback is going to occur at some later time. And we're not sure if it's going to be a millisecond later or a minute later, but it will be a delay. So let's take a look at actually some of the code that we're going to develop here. So we are going to define a callback function, and it will run after a set of data has successfully been retrieved from an online service. And so here's what it's going to look like. We're going to have a button click for get weather by name. And we are going to call this service called the weather service, and it's going to get the forecast. So it's some function, and it's an asynchronous function. So following that, we're going to have two options. So when this is done, we are going to have a on error. That's a possibility that nothing came back or it was badly formatted. Or we're going to have a response. And you can see in the response that I am updating an array adapter. So I'm showing a list on my UI. So this is the actual Java code that we're going to be coding in a tutorial in the next video. So this asynchronous process is going to help us with what's called non-blocking code. So non-blocking code is to allow other tasks in an application to continue running and not block up the user interface. So you can see in the example in this timeline here that we, in the first example, would be a synchronous execution. So we stop all processing and wait for a response. However, in the second example below, you can see that we are going to start the external process, the network request, but then we're going to go on and do other things. We're going to keep processing the threads, you might say. And we're going to have things going in parallel. And so it'll prevent the application from freezing up. So the first process will continue executing, and then the other code will work in the background. In Android and in all applications, the user interface thread is important not to block. So we have a task list here. You can see I've got 4 applications running on my application. We don't want them to stop. There is a literal loop, or a looper they call it, an infinite loop, a while loop, that continually checks on each task and gives each task a little bit of processing power. So it's the scheduler in the operating system. Now, if we were to stop one of those tasks and it had to sit and wait for a response, then your whole phone will freeze and it'll appear like your application is dead. You might get an application alert that says the process isn't responding. What do you want to do? Close the app? You might want to. And if the user does that, then you'll probably never come back to your app. They'll call it a buggy app. and you don't want that to happen. So instead, what we're going to do is we're going to use this interface thread, which is responsible to keep the user interface running. We're not going to mess that up. Instead, we're going to offload this to a background task, and we'll let that handle the retrieval of network information. And that way the looper can continue to go on, and the user can continue to choose menus and buttons and just wait for the weather to get updated in the second app. Now, to do all this network requests and all this looping and background processing, there are libraries that are built to handle these kind of things. So Android has several libraries available to us. There's one called Volley and another one called Retrofit. So Volley is the official documented library that you would find on the Android tutorials, and that's the one we're going to use. It's been around for a long time. However, there's another one called Retrofit, and it's actually probably more featureful. It might be a little bit easier to use, and it's actually shown up recently in the process called the Jetpack. So Jetpack is a collection of libraries that are considered best practices by Google. And so even though we're not going to use Retrofit, it might be a better choice for future programming. But they work very similarly, so the concepts will be the same in either library. So here's what's ahead of us. We're going to create a weather application using an API and an Android. So we're going to install the Volley library. We're going to parse a Json data feed, and then we're going to use asynchronous methods using callbacks to update our user interface. And so all of that stuff is just ahead of us. So let's take a look at how to build a weather app using Android.
Okay. So a little bit of, background on where this fits in, and he mentioned Volley, he mentioned Retrofit. Volley's the one we're talking about today. Retrofit we'll talk about next week. There are, I would say, there's a few more than minor differences between the two, because they do actually work in different ways, and they're really designed for different purposes. So we'll kind of see that as we walk through Retrofit next week. But I wanted to kind of give you some that background and the intro to things. Does that help? Kind of putting things in perspective of where we're at.
Yeah, it helps a little bit.
So just to review
Hi.
briefly, the process of using Volley, as you would have seen, as you see in the reading assignment, one of the first things you have to do to use Volley is you have to create a request queue. So the request queue at any given time is only running one request. So it sequences those requests. You can just add them to the queue. They'll get done in order, and that way you're not using a bunch of bandwidth all at once, for doing 20 requests at once, but you can batch them up so that they run in sequence. So that's useful in terms of battery usage, but it's also useful in terms of making sure your app doesn't cause a bottleneck for a lot of other apps. So in typical sort of fashion, we're usually going to want to set this up in a way that our entire app only has one request queue. You can set it up in other ways, and there is some value to that depending on what you're building, where you may want more than one request queue so you can have requests go in parallel. But the usual kind of case for using this is usually you just want one request queue. So if I want just one request queue, where might I want to do the creation of that queue?
Mr. Smith, did you go back to the slides?
Sorry. Yes, I did. And I forgot to switch again. I will switch that. Good news is I can switch it back here and it'll stay.
If there's only one, then it would be the main activity?
Main activity? Well, can there be more than one instance of the main activity?
No.
The answer is incorrect. Yes, the main activity can actually exist and be multiple copies of that. That's a common mistake. You cannot assume any activity, whether it be main activity or another. You should never assume that there's one instance of that. That does not hold up in practice for a lot of reasons. And part of that is that, remember, anytime you go from one activity to another, right? Remember, activities get added to the stack. So you can potentially have multiple copies of main activity on your backstack, right? Because if I send a intent and say go from this activity to main activity, I've now just added another copy of main activity to it. Other things that can happen is if you go through a notification that takes you back to main activity, that can also lead to another copy of main activity. So there's a lot of ways there, whether it's because of your intents you're sending around, whether it's because of notifications, and or you're leaving an app and coming back. You can't really make the assumption, and you shouldn't make the assumption, that main activity is only one single instance. That doesn't hold up. Now, Troy, you're right. The application is a good place to do that. Why would the application be a better fit for that need of ensuring that there's one instance? So you can get the application class the object can get created more than once in a few different ways. So if the application shuts down and then restarts, then you'll get a new copy of it. If there's more than one what we call process running, then each of those processes would have an application. But you are guaranteed that for each process that there will only ever be one application instance. And you're also guaranteed, remember the onCreate method, that's the method that we override on our application class. That onCreate is only ever called once. That is guaranteed by Android. And it's only ever called once per process. So again, if your application is running in 2 or 3 different processes, which can sometimes happen, each of those will have a different copy of the application, but that's actually okay. That's usually fine and acceptable. But yeah, so having it in the application does a better job of kind of guaranteeing that you have only one instance of it per process, which is really what you want. It also guarantees because the app that it gets run at the right time and created at the right time. Because your application can start or be running in the background. Say you're doing notifications. Say the work manager is kicking off. There's no UI, which means you don't have an activity. So if your application is running in the background, the user's not seeing or not actively in the app, there may be no main activity. So you can't rely on even there being one instance of main activity. There may be 0 instances of main activity. But there's still going to be the application. If the worker starts up and runs, then if your work request picks up and running while your app's not running, the application still gets created. Cool. So yeah, application is the right answer. There is where I usually put this if you want to guarantee that there's only one.
Say that again. Where does it go?
In the application class. So similar to how we set up, you remember we set up the data sources and had the data sources be owned by the application? I do the same thing with the request queue. So I would put this line of code into the onCreate method of the application is where I would recommend doing that. And then get the request queue in all the other classes that you need. Just ask for it from the application. Now what's shown here, you're saying Volley new request queue. That's the easiest way to set up a new request queue. Set up a request queue. That will set it up with all the default parameters, which are honestly usually good enough. One of the articles, if you read through the perusal reading assignment, will go through and talk a little bit about how, some additional things that you can do and the nuts and bolts of how you can get in to configure that. I will say that a lot of the configuration that you can do for the request queue, unfortunately, isn't documented. So that's kind of something you just kind of have to dig around through the code to get really into the nuts and bolts of how to set that up. But for our cases, for what we're doing this semester, using this utility method is sufficient. It's plenty good enough to just say, give me a request queue with the default settings. That will be good enough for what we're doing this semester.
Is there a reason why a lot of it's not documented? Is it just like not super useful or something?
I don't entirely know. I think Google slightly default there. The other thing is that they put their primary documentation on the training pages, and one of the problems with the training pages is they don't provide any way for people to submit changes, right? So Google has to recognize that there's a problem with their documentation and go fix their own documentation the way it stands, which is a really big deal. So I wish that they had their documentation over on GitHub, because if it was over on GitHub, then everybody that uses it could very easily submit, hey, here's a way to make your documentation better, and here's something I see that's wrong with the documentation. But as it stands, I think that's really on Google's part. The problem is how they're hosting the documentation, and that doesn't really provide a way for feedback or easy changes. Does that make sense?
Yeah.
It's also just a matter of, this happen. It's an open source project, so a lot of open source projects are really small teams, oftentimes one or two developers, and oftentimes those developers that may not, their time is split between writing code and writing documentation, and oftentimes, honestly, they don't even know when their documentation sucks. And plus, usually they're not, if it's an open source project, oftentimes they're not getting paid for that project. So that makes it extra hard for development hours, especially documentation, to get written when, it's not your primary job, it's something you're doing as a hobby. So I think that there's a bunch of reasons why that is, unfortunately, but I've seen that with a few different open source projects. Picasso's honestly the same thing. I love Picasso. It's an easy to use library, but some of the stuff I even showed you on the slides isn't in their own documentation, even though it's in their API. Does that follow?
Yeah, and I also saw somewhere in the reading, you said something about you pushing up like a poll to the main or something.
So one of the nice things, with open source projects is the code's out there, right? And any project that's hosted on GitHub, you can submit changes to it, actually. It's something called a pull request. So a pull request, you say, you fork the library, you fork the GitHub repo and say, hey, I'm going to make my own version of this, but then you can submit your changes back to the original repo. So you can say, here's some suggestions to make your code better. So that's one of those things that you can do anytime you've got a library that's hosted on GitHub, which most of them are. Whether you're working with NPM, most of the NPM actually all of the NPM packages are on GitHub. A lot of these projects, a lot of these libraries, the third-party libraries that you're going to use with Java and Android, they're also on GitHub. So a lot of these open source projects have moved there, and so you can submit a pull request and say, here's a way to make your code better, or submitting changes. Does that make sense?
Yeah.
So there's one of the things that's been kind of missing in their API, really an oversight and more a bug than anything, was something related to, hey, there should be this constructor, there should be this method, but for whatever reason it got missed. So that's one of the things over spring break, I was looking up and reading and doing stuff on this. So I submitted a pull request for, hey, here's a way to make Volley better, basically. So that's in there. They've accepted it, and that'll come out with whenever their next release is, but is not something that's currently available. Does that kind of answer your question, Corey?
Yeah, it does.
So open source is an amazing thing. The strong the benefit of it is that in theory anybody can submit changes, make the thing better, and you can audit it and see what's the quality of the code underneath and things like that. So that's a lot of projects have gone that way instead of being the traditional closed source approach where here we sell you a product, here's the price you're going to pay for it, but you can't get the source code inside of there. And if it doesn't work, which is Microsoft's kind of track record, if you have a problem with .NET, tough cookies. It just broke. Maybe Microsoft will fix it. Probably not. So your options are basically live with it, find a way to work around with it with most of the Microsoft libraries, or go use somebody else's library. Just ditch the Microsoft library and go use something else's. So that's been the traditional model. I think that this is a lot better. So anyway, getting back to this, so the request queue, that's kind of the first thing you have to have. And so the request queue is what's actually going to run and do your requests. So once we've got a request queue, now we can actually do our work. We can say, let's make some requests, let's add them to the queue, and they'll get run. So a kind of very simple, basic example of setting up a request. There's a class called string requests, subclass of request. And so what it does is it says, okay, just go to this URL, give me back the contents as a string, right? So the name string request doesn't mean that you're sending a string, which is what a lot of people make the mistake of. And I agree with that's like what I would expect, that it's sending a string, but it's not actually sending a string, it's receiving a string. So it's expecting that, you just say, hey, whatever we get back from that URL, just give me back as a string. And so that constructor requires a few things. It requires your method. So here I'm just saying, let's do a get request. I could have also said that I wanted a post request or put request or delete, kind of using the same method. I give it a URL. So here I say I just want example.com. And then I can provide two callbacks. The first callback is going to be, what do you want to do when you get the response back? And the other one is, what do you want to do if something goes wrong, right? So you'll get a Volley error, which is a subclass of exception, to say, what do you want to do if there's a problem or there's an error, there's an exception, the most often case where you're going to get that Volley error is just that the internet's not connected, that they're not connected to the network, where they're offline, whether it be because they can't reach the cell towers, they're too far away from them, or they're inside a parking garage or wherever it is, inside a tunnel. There'll be a lot of reasons where you can get an error, but usually it's because of their internet connection. But it can also be because the page doesn't exist. So for instance, if I get a 404 error, it automatically will go down here as that. Or if I need to be logged in, I get a 401. Again, it will go directly to Volley error. So you really only have two callbacks where you have to say, what do you want to do if it's successful? What do you want to do if it fails, right? So if it succeeds, I get a string, that's the part where string request comes in, because the response comes back as a string. And here I'm just saying, well, let's just log it, right? Let's log the response and let's log the error, right? In reality, I'm probably going to put some more code into those callbacks. Does that kind of make sense to everybody so far?
I think so, yeah, for me.
So, and then, once you create the request, you also have to remember to add it to the queue. If you don't add it to the queue, it'll actually never run. So you got to make sure that you do that part. But that's, the gist of it for making a simple request. And this is where that replaces, remember all the code that we had to write were related to the HTTP URL connection. You remember all that code that we had to write? Well, this is basically replacing that, right? So you don't have to write your own async task. You don't have to write an HTTP URL connection, all that logic. You just say, well, here's the URL, and let's go fetch that. Now, you will still have to use like the URI builder, for instance, to build up a URL as you need to add parameters. But once you're done building it up, you just provide it to this request object as a string. So this is one simple way to do it. The string request has a few limitations. One of them is that it doesn't really provide you a way to send data to the server per se. So you can set the method to post, but you can't really send any data along with it. Like you might do with, submitting a form. You want to submit the fields in the form. It doesn't really provide that. There are some ways to extend it and make that happen, but it doesn't provide that out of the box. Another thing in there, because it's delivering it and just delivering it as a string, let's say you get JSON or XML or whatever you get back, if you need to parse that, this will not do the parsing for you. So you're just going to get a string in here, and so in this handler, you would have to parse the response. And, that's fine if you don't know what kind of response it's going to be. If it might sometimes be XML or HTML or JSON, you don't know what it's going to be, well, then this is probably this may be the one you want to choose, is a string request. But most of the time, you know what it's going to be, and it should always be the same thing. So it's probably always going to be JSON. In that case, you'd like to parse it. The catch is both of these handlers, the response handler here and the error handler, both of those run on the main thread, which is generally good. You want to be able to update the UI there, so that's why that's done. But the catch is that, well, now if I get back a very big, let's say I get a megabyte of JSON data, I now need to parse that. Well, if I parse that here, I am blocking the main thread while I parse that, right? So let's say I take that megabyte of JSON data, and it just takes me 15 seconds. It takes me 15 seconds to parse that. What's going to happen? What's going to happen if I'm blocking the main thread for 15 seconds?
User's going to get upset.
Okay, user's going to get upset. What else is going to happen? Why are they going to get upset?
I forget what it's called. It's a three-letter abbreviation or acronym, or it says wait, ANR or something like that.
Yep, that's it. ANR, which stands for Android or application not responding, or Android not responding. So you're going to get an application not responding, an ANR message pop up saying, hey, things are frozen. Do you want to kill it? But the reason that they're really going to be upset is not just because of the pop-up that then ended up crashing their app because they just clicked OK on it. The reason they're going to be upset is during those 15 seconds, they won't be able to do anything. They won't be able to type anything into a text field. They won't be able to navigate to another app potentially. They literally their phone's going to be stuck for 15 seconds where they can't do anything. They can't tap on the screen and make it do anything. And that's a big deal. Does that make sense?
Yeah.
So this is the simplest version of the request, is the string request. In reality, we're not going to use that. It's an okay as a testing and just to kind of experiment. And if you do have just plain text coming back that you just want to show it without doing any parsing or processing with it, then that's okay. But in reality, we're not going to use this for our applications. So more than likely, the data we get back is going to be JSON data. So in that case, we'll use a JSON object. We can use a JSON object request instead, and that will parse it as a JSON object. Now, this version here uses the org.json libraries. So it's going to come back here as this JSON object thing. As I've kind of mentioned in a previous lesson, There are some issues with that JSON library specifically, and it's not really great. You can use it, but I find that more than not, this leads to applications that have a lot of bugs, and if they change just the slightest thing on the server, your application starts crashing, because it's very, very strict about kind of validating and throws exceptions in a lot of cases where you wouldn't expect it to throw exceptions. Okay. So you can use that to parse JSON if you're willing to use the org.json libraries, but I would ask that you don't. Similar to this, there is a JSON array request. So there's a JSON object request, JSON array request. They're very similar. The difference is that what data they're expecting to get back. Now, remember, that as I mentioned with the string request, the name of that object, the name of that is really about what you're expecting to be the response, not what you're sending, right? So a JSON object request is expecting to get an object as a response. A JSON array request is expecting to get an array as a response. Okay? But other than that, they are very, very similar, right? So, basically you're creating a different class and you get a different response. In reality, what we'll do and what we'll want to do for our purposes for this class is we're going to use JSON to parse the data instead of the org.json libraries. That's not built in directly to the JSON's not directly supported by Volley. So you do have to write your own request type. You have to create a custom kind of request called JSON request in order to enable us to do this. Now, there's a code example in the reading assignment. I won't go over that here, but I would strongly advise you read through that, because I'm going to expect us to use that for the labs and your final project. Okay, so JSON request is really the one that we will be using, but that's a class that we have to create in our own applications. Okay. Questions so far?
So does that change how we call the JSON then?
What do you mean, how we change the JSON?
So, in the previous apps, we called it a certain way. Does this JSON request give us a different pathway to get that JSON?
So it gives us it kind of takes the step of parsing the JSON and moves it to somewhere else, right? So what it means is if I create this custom request here, I don't have to implement all the JSON stuff every time. I still have to create this model object. So here, the time API response class, I still need to create that. It doesn't take away the need to create your model classes. Does that make sense?
Yeah.
It just takes away we're just going to take away the boilerplate around setting all this up. So what used to be 100, 200 lines of code goes down to this. Does that make sense?
Yeah.
So we're still using JSON. It's just going to be, a lot of the boilerplate is going to be going away. So that's the part to know. Okay, so let's look at some questions. I went through, things that people had asked on perusal regarding the reading assignment, and so I've added a few of those in here. We'll talk about them real quick. I think I've already answered some of those, kind of as we've gone through, but I do want to take a look at those and have a chance to discuss those. Once we finish those, I'll open up the floor for additional questions, and after that we'll have a short quiz. Okay?
Yeah.
So one of the things that it said is Volley in the documentation, in the reading assignment, it says Volley always delivers the parsed response on the main thread. And Paul, you'd asked, okay, well, it does that, right? But does it have to do that? And the answer is it really doesn't have to do that, but it's desirable that it does that. It's desirable that it does that because of where it's intended to be used. So the idea is that when you get the response back, when your callbacks get called, you want to use that to update the UI. So if they get called immediately on the main thread, then, okay, you can immediately go update the UI. You don't have to offload it again from the background to the main. That's already taken care of for you. Does that make sense? So in your response handlers, the error handler and the listener, those two callbacks, you can just immediately update the UI if you're working in an activity.
Yeah, what I meant by asking that is like that's its purpose, right? I mean, if you're not going to display anything on the user interface, then getting the information, I mean, I suppose you could update something in the background that the user doesn't need to know about, but the whole purpose is to display information. That's what I meant. That's the sense I meant.
Well, no. The purpose of Volley is to make HTTP requests, not necessarily to display information. Oftentimes, that's the reason that you're going to get the data in the first place, is because you want it to show it to the user. But you could easily have a process that's running in the background and maybe looking for new data. So you're watching the NPR newsfeed and you're watching for new stories. That doesn't directly update the UI. Does that make sense? Like, it may fire a notification, but it's not quote-unquote updating the UI of the application. Does that make sense? Yeah,
I think I'll get it. We're not breaking any new ground here. It's just a different way to do things that we've done before.
Yeah.
Did we cover, though, why would we learn Volley when retrofit is part of Jetpack? It seems to do the same thing, and it's the more modern, the way things are going, and probably better documentation. Is it just because this is so...
Just to give you some more tools. You some more tools and options there. Volley's really good if you have just a very simple apps. If you have very simple applications where you just need to do, especially where you just need to do a one-off, where I'm just going to make one request to an API endpoint. Maybe I have one or two API endpoints. Maybe I don't care about the entire API that they provide. Then Volley's a good fit if I just need one-off requests. Does that make sense? Retrofit's more built if you want to model their entire API. Retrofit provides a lot more benefits if you say, okay, I want to look at 20 different endpoints and reducing the boilerplate code there. Does that make sense? It's built specifically for things that follow the REST API pattern. Not everything is a REST API, and not everything follows that standardized sort of pattern of URLs and such that we discussed last semester. So for things that aren't strictly a REST API that don't fall into what retrofit supports, Volley is an option. Does that make sense? So retrofit has some constraints about, it's pretty general, but it does have some expectations about how you're sending and receiving data. Okay.
Yeah. Mm-hmm.
So it may or may not work with every API on the internet. Versus Volley does actually work with anything. If you can request it over HTTP, you can do it with Volley. But you may or may not be able to do it with retrofit. Just because they're two different approaches. One of the things that the documentation knows well, this is the question that was asked about. It says Volley is not suitable for large downloads or streaming operations since Volley holds all responses in memory during parsing. So as you're making requests with Volley, you go and grab, it actually reads the entire content of the response, does the parsing, and then you do the processing of it. So it's not good for things that you need to be streaming, where maybe you're saying, I want to get 1 million documents and I want to see them as they come in. Or for instance, remember we saw what was the library?
Are you talking about Oboe?
Oboe, yeah. Remember how we talked about how using Oboe to stream the data and it kind of pops in as we receive it? So Volley doesn't do that. And Retrofit actually doesn't really, at least in my experience, do that either. So that's actually something, if you want to do streaming, really the only way to do that right now is by using HTTP URL connection directly. So that's you have to be much more low level to deal with streaming. So streaming is one thing that comes up. It doesn't support that. It's also not good for large downloads. Say you have even just a megabyte of data, just an image you want to download. It's not necessarily the best thing for that because of the amount of space that takes up in memory. Oftentimes what you want to do is just say, okay, I'm going to go download that file, save it to disk, and then I will read it from disk. That usually ends up being more performant, more efficient than keeping the file in memory. It's usually better to just go ahead and write it to disk and then read it from disk, which may seem like extra work to write it to a file and then read it from a file, but in reality it usually trades off, especially because you end up reading from that file more than once. So it means you don't have to go download it again. So that's usually what we do. One of the classes that's built into Android called Download Manager, as they kind of mention, is a better fit for that. So Jonathan, when you use the Download Manager, you get to specify where that goes. But you actually are limited in terms of working with files on Android as to which folders you're able to write to. So every app in Android gets its own folder, and you have free read and write access to your own folder, to your own applications folder, data folder, and cache folder. But you do not have free access to other applications' data. Does that make sense? So you can write it to your own folder, but you can't write it to just anywhere on the device. But that's oftentimes fine. The cases where you run into needing to access other folders are things like, well, what if I want to put it on the SD card? If I put it on the SD card, then multiple apps can access it, and then I can potentially pop the SD card out and go plug into the computer, yada, yada, yada. So you can write to your own private folders. You can write to the SD card. If you need to share, sometimes you find that you need to share data from one application to another application. Say maybe you want to take a picture with your camera and then post that image to Instagram. Then there's some more communication that you have to do to talk between those two apps if you're not just going to put it on the SD card, which is usually not what you want to do just because of security constraints. If you put it on the SD card, then anybody can read it. Anybody can pop the SD card out. So it's not secure in any way, shape, or form. So there's some tools around that. We're not really going to talk about that here. So what I will say is really Picasso does a much better job working with images. There is some marginal support for images in Volley. But it doesn't support things like transformations. So like needing to resize the image down and crop it, that Volley does not provide those things. If you want to do other image transformations, say for instance, maybe give it some sort of filter, maybe give a sepia filter, a black and white filter, you can do those things actually with Picasso. You cannot do those things with You can't do those things with Volley. It doesn't provide functionality for that. Also, things like, we saw you can put placeholders in and you can say, show this image while the file is downloading, or show this error show this image if there's an error downloading the file. Volley doesn't provide that. So Volley's, while it can be used for images, Picasso is just a much better tool when it comes to images because it's designed strictly for that. So, yeah. Does that answer your question, Jonathan, about the folders and the locations? Cool. Yeah. And to respond to Daniel's question, I would say, usually it's better as far as images are concerned to go ahead and cache them. Just because it might seem like they're pretty small. They're actually big enough that you want to avoid keeping them in memory as much as possible, because they do eat up into your space. Even 10 megabytes is a lot in terms of space usage. One, as Jonathan had pointed out, they're, even though we have, say, 2 gigabytes on your phone, most of that's already reserved for other things that are running. So there's usually not a whole lot of memory that's available. But it's also just a fact of realistically, we're pretty constrained. We're pretty constrained about how much memory overall is available. So the trade-offs really are not usually there in the favor of keeping the images in memory. It's usually better to have it just put them on disk and only read them and have them in memory when you absolutely need to have them on screen.
Okay.
So, yeah, having memory, it is an important thing. Even if you say, let's have 20 images in memory, that can be an awful lot of memory. The other side of things is, because of how garbage collection works, garbage collection has some issues with large objects that stick around for a long time. So you want your objects to be short-lived and generally small. The images don't really respect those limits. Anything that's a megabyte or larger, you have to do special things to work with the memory, with the garbage collector. Because the typical approaches don't work. Another question was asked about canceling a request, and there's a method called cancel that you can call on your request object. Volley guarantees that once you cancel a request, it's not going to call your response handlers. So whether it's the one that receives the response or your error handler, those are not going to get called as soon as you cancel it. Now, the case where that comes in is really you're only going to be canceling what they say pending requests. That word pending is really important. You're only going to cancel the requests that are in flight or haven't completed yet. You can cancel a request after it's completed, but it does nothing, right? Because we've already run the listeners have already been called. So nothing was going to happen anyway. Does that make sense, Paul? So the
listeners were already called.
They're already called. If you cancel it after it's done, the listeners were already called, so canceling it really doesn't do anything.
What starts the canceling action?
So you call cancel. The reality is what initiates cancel can be anything you want it to be. It's a method. You can call it at any time you want to. But typically the places where we call that would be things like on stop or on destroy. If you say your activity is going away, well, I don't care. I don't care about the response from that request anymore because my activity is going away. I would have no place to show the data. Does that make sense? So you would usually cancel it in the on destroy method.
Okay, we'll see it later. I think it'll make sense. Once I see it in code, then it comes together.
Yeah. You'll see it. I mean, if you're not using a worker, you'll see it. Once you're doing a worker, it's a little bit of a different story. But in terms of putting it into an activity, basically that's where you're going to see this in onDestroy. As you asked, could this be clicking a button? Yes, it could be a button click. There could be a cancel button somewhere literally on the UI. That happens sometimes. That would only happen for things that are long running. So if this is like going to take a minute and maybe we're showing a progress and saying, you can't do anything until this is done, until your request is, your order's processed or whatnot, maybe, or before this document is saved, maybe you would have a cancel button there. But more than likely, we don't usually have that many in way of cancel buttons, because we usually want these to be fast anyways. Usually fast enough that you would have it wouldn't make sense for there to be a cancel button there. Or things like, for instance, if you've initiated an order, you're going to go buy things. Well, canceling would be a big problem, right? So we don't generally provide a quote-unquote cancel button for people, even though you could. We don't typically do that. So it's usually just when the component that initiated the request is being destroyed. So we would cancel it there. Another question was asked about, what's the difference between JSON object request, JSON array request. As I kind of mentioned that, the difference there is based on what you're receiving, right? And yeah, it's the outer level. It's the big thing. What does it start with, right? What's the first character in the response? If the first character in the response is a square bracket, well, that means it's an array, and you should use JSON array request. If the first thing in the response is a curly brace, well, that means it's an object, and you should use JSON object request. Does that make sense? So
yeah, I was pretty sure that was right. I just wanted to confirm, because many times I'm surprised. I assume, and I'm wrong.
Yeah. So it can be either. It's worth noting that neither of these provide a way. If it could potentially be one or the other, you're really left guessing, right? You have to say, I know what it's going to be before I get the response. They don't provide a way to say, well, if it starts with a square bracket, then do this. If it starts with a curly brace, then do this. But yeah, it's the outer thing that matters. So it could be that you're getting an object, and that object could have an array inside of it. That's perfectly fine. You could have an array that comes back that's an array of objects. Both of those are fine. You can have objects inside of arrays and array inside of objects. So the thing that you pick out is the largest one. And yeah, I think most APIs that I've seen, a large in part, most of them return an object. And oftentimes, including like the NPR one, the outer thing that they return is an object, and within that is the array of stories. So most APIs that I've seen do actually return a object all the time, but there are APIs out there that you can write and work with where it also makes sense to return an array. So they do exist. I would say that they're a little bit more rare. You might, the most common place where you'll find those, if you want to say, well, let me get the list of all products, or let me search the list of products. Those are places where you will oftentimes find an array, or maybe you have a list of things that you want to populate a dropdown with. So for instance, if I'm talking about cars, I have the make, model, and year. I might return a JSON array of makes. I might return a JSON array of models. I might return a JSON array of years. And so those are other places, if I'm populating a dropdown, where you might see an array. Okay?
Yes, thanks.
There was one question on, setting up when you're setting up a custom request queue, you can specify how it's cached. So the default one they use is a disk-based cache. So the files, the responses that it gets are saved and cached on disk. If you kind of build up your own request queue, then you can specify what is the cap on the size of that cache. As I kind of mentioned with one of the previous things with the download manager, that cache is a folder that's private to your app. So in fact, here what we're seeing context.getCacheDir, that returns the cache dir for your app. And so that's in a specific place on the device. I think the path to that is, it's like /data, your package name /cache. And so it'll put it under that folder, which is private to your application, and this would limit it up to a megabyte. Honestly, I say a megabyte is probably large. That's probably the biggest it needs to be, because again, really with Volley, we're just caching JSON. Really, that's all we're caching. If we were pulling down images down with Volley, then we would definitely need a larger cache than a megabyte. A megabyte would not be big enough. So if I was going to download the images, I might set the cache to like a gigabyte if I had images as well. But we're doing that with Picasso. Picasso's dealing with the caching for that, so we don't need to be worried about that cache. That's kind of a separate deal. So all we're concerned is caching JSON. JSON overall tends to be pretty small. Because it's text-based and because JSON inherently is a lot smaller than XML, which is why we use it. One of the reasons we use it, XML is very large. It takes up a lot of space. It's also very hard to turn into objects to actually work with, to parse and things like that. So that's where we're going to use JSON because it's easier to parse and it takes up less space. So, it can be pretty small. Your cache really doesn't need to be generally bigger than a megabyte. But you could make it bigger if you wanted to. Does that answer the question?
Yeah.
Cool.
I've seen a lot of apps with an excess of 100 megabytes of cache.
Yes, I have too. That's usually a sign that they're caching media. Not always, but often that's a sign that they're caching media like images and video and audio. Those things can easily blow you up to 100 megabytes or even a gig of cache. Games also same story. Games actually usually have a very large cache because you're working with 3D assets and 2D assets and all the other things that go into making games. There's a lot of media associated, so usually the cache is quite a bit larger for game development. But for business applications, yeah, a megabyte is usually good enough. So I don't usually need to mess with that in terms of making things that we need. Now, so those are the questions that I was able to pull off that were out there when I was prepping my slides. Are there any questions I missed? Any questions you wanted to ask that I didn't answer already?
I don't have any.
Okay. All right. If something does come up, feel free to ask it. And what I'm going to go into now, though, is I've got a quiz prepped about the Volley stuff, the reading material, and what we've discussed here. So that is now live. That is now live on Inside Ranken. You'll find it under Unit 5, listed as the Volley quiz. There's a 30-minute time limit on that. So if you would go take that now, and then we'll come back and discuss your answers. I am going to provide you all a retake for it. So this is just initially to get, kind of review where everybody's at and to discuss it. So don't think this is going to be something that's going to be final counting towards your grade. I just want to get where is everybody at, and then you guys will have an opportunity to resubmit the quiz. Cool.
Will the resubmission be later today, or will it be like tomorrow or something?
The resubmission will be due by Friday. So we'll do it today.
Okay.
I'll open it back up, and then you'll have until Friday to submit it again. Cool.
Yeah, and then after the quiz, can we get like a little break to?
Yes. Awesome. Yes, absolutely. Get a break. Stretch your legs. Get your food.
Okay, talk to you then.
Cool. So you got 30 minutes to do that, and so we'll come back at 2:30. Hello. Just going through your answers to the quiz and trying to provide some feedback. I'm most of the way through, but there's a few I still need to get to. So I'm going to go ahead and start going through some of the questions, and we can kind of talk about them and discuss them, and I'll finish grading these later today. So is everybody back here? Everybody in the room?
Yeah.
So first question was, what are the main benefits of Volley? And I see a few different answers. The big one that I was pointing to in kind of the slides was boilerplate, right? It's really mostly about reducing the amount of boilerplate code that you have to write and get correct. Because think about it this way. Every line of code you write is an opportunity for bugs. And so if you can write fewer lines of code, you have fewer opportunities for bugs. Does that make sense? If it's,
Yep.
especially if it's code that's repetitive, those are really, really hard to find bugs in, because you just kind of glance over the code because like, well, I've seen this 50 bazillion times. There can't possibly be a bug in that area of the code. But the reality is there can, right? And those are the hardest bugs to spot because you honestly just don't read those lines of code. So whatever you can do to reduce boilerplate also means that you have fewer places for bugs to come in. Because again, those are usually places where you forget to review and make sure everything's good anyway, so they can slip through the cracks. So that's a big deal. There's a little bit of performance in there, which I think a few people hit on there with network speed and caching. That's one element of it. But the network speed things are actually minor in the grand scheme of things overall, compared to making your requests simpler to implement. Another one I saw from a few people is they talk about is automatic scheduling. In reality, I think that, I don't know if you read that somewhere in the documentation, the word automatic scheduling. I would say that Volley doesn't really provide scheduling, especially not automatic scheduling. So, because the way I would think about what we think about scheduling, we think about, well, I want to schedule when it's going to happen, right? I want to say it's going to happen at noon, or I want to say it's going to happen when the network's available. Volley does not do that. It will not wait for the network to be available to try and run your request. Does that make sense, everybody? So even if there's no internet connection, Volley will go ahead and try to do it anyway. So it doesn't provide scheduling. It doesn't provide automatic scheduling. It does queue things up. So you can say, hey, I want to run these 20 requests, but you really have to provide the scheduling yourself, which is part of why we still need the worker and the work manager. Does that make sense? Because that's the worker and the work manager, those work requests is how we still provide our scheduling. Cool. Another thing I mentioned, how many requests can a request queue be processing at any given time?
Yeah, want to say one.
One, right? You can have a bunch of requests in the queue, but any given time, there can only be one request being processed, being executed. So a few people said that it allows for concurrent or multiple connections. That would imply, if it was concurrent, that would mean that it could do multiple requests at the same time. And Volley doesn't allow you to do that. That's actually intentional. If you use the HTTP URL connection classes yourself, then you can end up making more than one request at the same time. That can be actually a problem a lot of times, and maybe isn't, sometimes it's desirable from a performance standpoint, but more often than not, it's not desirable from other standpoints. So Volley actually does not allow you to make concurrent network connections.
It says right on the first page of the docs that you can do that with Volley.
Okay. Where can you point to me to which page and which point?
Second point on the Volley overview, first page of the
that
doc.
Would be from their documentation, and yeah, it says that their documentation was incorrect on that front. So it doesn't really provide that benefit. There's a lot of things in that list on the first page that says it should be able to do and such like that, and it's not. Daniel, you gotta recognize to know when you're reading marketing speak, and that's marketing speak, unfortunately, when you're talking about what they claim it can do and what it can actually do.
I would rather not have docs than have incorrect docs.
But that's things that I see sometimes on different places like that. Oftentimes, pretty much never can you trust a documentation to tell you what the benefits of that technology is. They're nearly always wrong. When they tell you what this is good for this, nearly always they are misleading you. Just a heads up. Okay. So that's one of those things that trips up a lot of people, and a lot of developers end up parroting, like, hey, well, I should use this because the documentation says it's good for this. And in reality, in actual fact, the places that technology ends up being good for is often different than what the company or the library will tell you for. And so part of that comes from learning the different options that are out there and learning where they actually work, and as well as using those and learning where they actually work. So that would be incorrect. It doesn't do multiple concurrent connections. So there may be a way to configure it to do that, and I know that they've been working on something in that regard, but it doesn't actually support that. It's all synchronous at the moment.
Yeah. I got a general question.
Yeah.
We're talking about a queue. By definition, that has to be one at a time.
Yes, you're right.
Right? It wouldn't be a queue otherwise.
Yeah, that is implied. It doesn't have to be, but that actually is technically implied when you're talking about a queue. If you're talking about a simple version of a queue, you're just talking about processing them from the beginning of the queue to the end of the queue. So yeah, typically when you're talking about a queue, you're talking about processing one thing at a time. It is possible to build things out where you have, say, multiple requests being processed at the same time, and you say, okay, I've got 3 different worker threads, and those are working through the request queue. And at that point, if you had 3 worker threads, then you could do that. I think that here's the gotcha. I think that Volley may provide that if you completely customize and work through making the request queue yourself and change how the executors inside of there work. But it really, with the default configuration, doesn't provide that. Does that make sense? Like, there may be a way to get that out of there, the multiple network connections, but they don't provide that out of the box, and nor does their documentation tell you how to do that. So, yeah, that's one of those things, and that's actually why I ask questions like that. I say, what does this actually give you? Because oftentimes it's not what's on the box. Oftentimes it's something a little bit different than what they tell you. Yeah, so that's that question, and let's talk about what it replaces. And I saw a bunch of answers. The real one that I would say is HTTP URL connection. Now, I commented on several people. If I'm looking for a specific class name, make sure that you get the spelling of that class name correct, including capitalization, as well as the actual words. Like, don't leave a word out. Needs to be actually exactly the name of the class, if that's what you're responding.
Are you sharing your screen, or are you meaning to be?
I'm not meaning to. I'm looking at your answers, but I've got those on a separate screen. I'm not showing what people actually answered. So,
okay.
Yeah, so just make sure that you're putting that in there. Another one that I saw a handful of people answer with is retrofit. Volley is not a replacement for retrofit. It's rather more like the other way around. Volley is a lot older. Retrofit is newer. You remember in the video they said retrofit was introduced in 2019. So retrofit is actually so new that I wasn't aware of it until middle of semester, when I was looking around and reading actually a Kotlin tutorial, and looking at other things that were out there as far as tutorials. So retrofit's actually a new one on the scene. It's very, very young by comparison, compared to Volley. Okay, so it's actually the other way around, where Volley is where retrofit's almost trying to be a replacement for Volley, rather than, Volley is not a replacement for retrofit. And when should you use another library? And this also comes back to the benefits, right? So, part of understanding the benefits and part of understanding, where to use a library is actually really important, because what you're going to find is, regardless of what technology you choose, pretty much there's always going to be 3 or more options. There's usually more than one way to do the same thing, or more than one technology that you can pick off the shelf to implement it. So the question is, when should you use it and when shouldn't you use it, right? And so that means you have to understand what benefits does it provide, what are the things that it doesn't provide, and where is another API, another library, maybe a better choice for the thing that you're doing. Okay? So if I'm talking about, when does Volley not a good thing to pick? Well, actually, there was one of the things what was one of the things that I specifically picked up on one of the questions that I taught, that I pulled off in the slides. There was one of those that I specifically picked from the Bruzo reading.
One that you specifically picked? Mm-hmm. I'm sorry, I didn't quite get the whole question.
So there was one of the questions I picked off from Perusal that somebody had asked, that said, it was in regards to something. They said, Volley is not good for blah.
Oh. Go ahead, Daniel.
Is it images because you'd rather use Picasso?
Okay, images is one. Vincent, you're right. Large media is another. What else?
Streaming.
Now, what do you mean? What do I mean by streaming? Do we mean like Netflix or Hulu, or do we mean something
probably
else?
image streaming. So like display as you download.
Okay, that's one thing. Like showing the data as you have, like kind of a loading bar from the top of the pixels down to the bottom. That could be legitimately another explanation of streaming. You could say showing the image as you get it, or streaming as in streaming services. But actually, when they talk about streaming, they actually mean something else. So streaming can refer to media, but in the case where they're talking about it in the documentation, they actually mean something different than media streaming. And here's a hint, they're still talking about JSON.
Oh, is that like where you like read and like parse the JSON as you're receiving it?
Yes. And you remember what was the technology we used with Node to do that? It was Oboe, right? So you'd need something like Oboe if you want to stream the data. Does that make sense? You want to stream a JSON or an XML through. Or you use with XML, we would use something called a Sax Parser. Does that make sense? So it's good for cases where you have basically small amounts of JSON that you're getting as a response. Does that follow? Small amounts of JSON or small amounts of just plain text. So anything that's outside of that wouldn't be a good fit. Another thing to point out, I think one person had said, well, you don't need it if it's too simple that you don't require it. Actually, I would say that Volley is best for small things, right? It's not good for big responses, a lot of data, media, but it's very good for small, simple tasks. Does that make sense? It's actually meant for that.
Yeah. So when you get down to it, really the only advantage is that you're replacing the HTTP request and the async task, which is tedious to type out and prone to error. Other than that, just sticking to the old method, that's okay.
Right.
You're just eliminating chance for errors.
Yeah. If you have something where you need streaming, well, you're still going to have to use HTTP URL connection. If you need something where you can display a progress bar and you can say, okay, this file is 10% uploaded, 30% uploaded, 40% uploaded, etc., you're still going to need to use HTTP URL connection. Like Volley doesn't do that if you need a progress bar. Does that make sense? Similar with media things. So it's really just in cases where we're getting JSON back. And what the next question is, I say it's great with small amounts of JSON. What is a small amount of JSON? What is a small amount of JSON? What's a large amount of JSON? So I would argue that 1 megabyte is already huge. 1 megabyte is already way too big for Volley. That's something, if you've already hit 1 megabyte, then you really do need to be doing streaming with that data more than likely. So when we're talking about small, it's actually going to be on the order of kilobytes. Like 10K or less is probably the right point for Volley. And really what matters not is the size of the data, it's the amount of time it takes to download. So if you can download the data in 16 milliseconds, absolutely Volley's perfect. And even if it takes, maybe if it takes, again, you're talking maybe a second, up to a second, then Volley's a great fit. Does that make sense? So if you can get all of the data very quickly in, say, a second or less, then absolutely pick Volley. But if it's going to take longer than a second, then you probably want something else. Does that make sense? Like, actually what makes sense is, what matters is the time it takes to get the data, not as much the size.
Does Volley block the UI thread while it's downloading?
It doesn't. It doesn't block the UI thread. It doesn't block the UI thread. So that's good, just like the other things with... That's the whole reason we use async task, right? So we don't block the UI thread. But
yeah, you said 16 milliseconds. I thought, okay, well, maybe that means we're blocking the UI thread.
Yeah, no, 60 milliseconds being like a single frame, and so that's the same kind of thing. Like if it's 16 milliseconds, it's just so fast that some of the other methods are not necessarily going to be a better fit. So yeah, basically yeah. But what I would say, if it takes a second or less, that's about the good happy place for Volley. If you have a small amount of data, you're talking about a few kilobytes, and you can get that all in a second, then great. If it takes longer than a second, then you need to look at other options. What was the next one? What class? We create so typically I think most people got this right. If you want to create the request queue, you're typically going to do that strictly in the application class, and then everywhere else will then use that request queue that was created in the application. It's not your only option, but that is usually what you want to do. String request. A few people pointed out as being testing. That's fine. There's only two cases where you would use it, is if you're doing a quick test and that code is just throwaway code, it's not going to go into production, or if for some reason you do need to get the response as raw text and you don't intend to do any parsing with it whatsoever, then string requests would be okay. So for instance, if I want to say, let's go get google.com, grab the HTML, and then just show the code of HTML, the HTML code directly to your user, then I don't really need to parse it, right? Or if I want to say, let's go get, I've just got some sort of tester application, I'm going to go grab the JSON and just show it to the user as JSON, as code, well, then I probably don't need to parse it. Does that make sense? So if I have no parsing I want to do with it, then a string request is okay. If you have any parsing whatsoever you want to do with a string request, you probably, with the request response, you should probably do something else. Let's see. Json Object. And basically, so JSON Object request you should use when you're expecting a JSON object back. JSON array you should use when you have a JSON array coming back. And if you, let's see, as far as custom requests, there were a few different responses that I saw. A big thing to look at is what I've written into the custom request thing. There's a lot of things there. A big thing I want to point out with that one is, in terms of creating custom requests, I'm asking for specifics. And I saw a number of people who just said to do something special, right? Or to do something custom. It's like, well, you can say that and write that without having read any of the material, right? So what I'm asking for is what are those things that would drive you to making a custom request? What are those things, that areas where the built-in set of requests don't give you what you need, right? So I'm looking for specifics on that question. And so some people gave me specifics, some people didn't. Okay. Does that kind of answer any outstanding questions that people had with the quiz? Are there any questions remaining? Okay. So to read further up on this material, I'd strongly advise you to see the revised documentation that I provide on Perusal. That's your best source to read more up on this material. So what we want to do then with the remaining time is just to do maybe a quick demo example of where this fits in. One of the things I wanted to do today is to talk about how to use the Work Manager and Volley together. I don't think that we're actually going to have enough time to do that, so I'm going to push that part of it till tomorrow. So today we'll just go over kind of a very simple example of how can I pull data from the API using this.
How long are we watching YouTube?
You can absolutely, yeah, please go along. So I'm going to start a new project.
You're going to share your screen too, yeah?
Am I not sharing my screen? Oh, I guess I was not sharing my screen. There you go. Okay, so I'm going to start with an empty activity. And what do I want to call this? Let's call this Echo Demo. And I'm going to put this Echo space demo. And I'm going to put this under, let's see, Unit 4. And let's put this under Volley. So Unit 4 Volley slash Echo Demo. So I've got a space in the name of the application, but not the folder. So you can code along. You don't have to. I'm not gonna take this as a grade either way, so it's really up to you. So I'm gonna go ahead and just get started in here. So I've called the project Echo Demo, and what I'm going to be using, there's a few APIs here that are provided that I've created as kind of testing to do some labs and experimentation with. So what I'm going to be using is the API / Echo pathway here, which basically just allows it allows you to send something. So for instance, I can send some parameters to it, and it will just return those things back. So if I say and foo equals bar, then it's going to come back here with foo equals bar. So it's just going to send some, I can provide it some parameters and just feed back exactly those verbatim to me. I think that I didn't click stop share screen, so there must be a problem on Discord side.
That's working now.
Okay. So I restarted it, but I don't know what went on there. So that's what we're trying to get to, right? So we're trying to get to having it, connecting to this simple API here. So in terms of doing that, we can start with the first thing I need to do is add the dependency, right? So if I look into the documentation, what is the dependency that I need? So I need in here, I need to add in implementation to my Gradle, and the path to that is com.android.volley.
You're sharing your Chrome window.
Oh. I swear I do not know what's going on with Discord today. Usually it's not acting up as poorly. Okay, so you can see Android Studio again. Yes, no?
Yes, yeah,
Okay.
yeah, we both see
Okay.
the browser too.
Okay, cool. So Volley, and what I need
what
is
happened?
1.20.
You disappeared again.
What?
It's
Yes.
back on the Google Chrome.
What in the world is it doing?
Oh, there we go.
Okay. I don't know what's going on there. It seems like it's just automatically switching on me, and it's never done that before. Okay. So that's the dependency that I have to add is implementation com Android Volley in order to be able to use the Volley libraries in my project. So going back to main activity, now that I've got that dependency in place, I can actually start using that. Now, the first thing I want to do is, as we mentioned, the first task is to create a request queue. I'm going to keep this example simple, so I'm not going to create the application in this case. I'm just going to keep it inside of the inside of the app, inside of the activity for today. So request queue, I'm going to declare that as a private variable. Internal to the onCreate, I'm going to say volley dot new request queue, provided the context. Now it's worth noting that you do need to make sure you're always providing it an application context, because you really don't want to leak your activity context, because that goes away and becomes invalid as soon as the activity is destroyed. So you want to make sure that you're providing it an application context to avoid memory leaks. So that's that. And then also on destroy, we want to clean up after ourselves. So basically we'll create it in onCreate, we'll destroy it in onDestroy. So here I'm going to say my request queue, we are going to stop. And I do need to in here check if the request queue is null. Reason being, if there is an exception, if something goes wrong with the onCreate, then it might not get down to this line. So for instance, if this throws an exception, the set content view throws an exception or anything above here, then we would not get down to here and we wouldn't have a request queue to stop. So we need to make sure that we check for those things in onDestroy. That's kind of a common sort of problem. So the next thing I want to do is probably create a request, right?
Mr. Smith, a quick question. What's the italics new request queue line 19? Why is it like that?
I'm going to guess that's because it's a static method. I'm going to guess that's because it's static. So I'm also going to add a reference to my request in here. That will allow me to cancel it as well. So should I need to? So request, and so boop, import class. And it gives you a bunch of different options because, well, there's a lot of things named request, which, you know, is an issue. But specifically the request that I want is com.android.volley. So that's the one I'm going to import. So I'm going to have my request there. And for, again, this is a simple example, so I'm just going to start by initiating that request as soon as the activity is created. So let's start that request. So the first thing I need to do is actually construct it. So let's just say I'm going to make a simple string request here. Now remember that, you know, first thing I need to provide is the method. So that is request.method.get. The reason for, you know, what's going on with these pathing is there's basically nested classes. So request is a class, and then inside of that there is an enum. Actually, here's it's an interface. So inside of that is a nested interface called method. Inside of that are these constant values. So that's kind of what's going on there, is because there's nesting in the classes. So request.method.get. The next thing would be the URL. So for me, that is going to be this URL here, which I have posted on. I have posted that on the Discord. So I'm going to go to this example service API echo, and I need to next provide the listener. So I need to say here, you can write these out not using lambdas. So for instance, using listener, request.listener, and request.errorListener. But it's a lot easier to, it's definitely, there's a huge benefit in writing this out using lambdas here. So that's what I'm going to be doing for this, is just using lambdas. And so this is the response that comes back, and I know it's coming back as a string because it's a string request. And so in here I want to say, well, what do we want to do with the response? So an easy thing to start with would be to just say, well, let's log the response. And so you remember, if I'm logging, I need a tag to do that. So I'm going to declare that real quick. So private static final string log tag. And so today I'm going to be using the traditional, just take the name of the activity. So main activity dot class dot get simple name. And so that's what I'm going to use as my tag. So let's say if that succeeds, if we do get a response, which we should, then I'm going to simply just log what that was. So we're going to say response plus the response that we got back. And otherwise, we got an error. So this would be volley error, call that error. And so in that case, we want to do something maybe a little bit different, but all I'm going to do is just log the error. So here I'm going to say error, and let's error getting response, or error failed to, or maybe I'll just use the message there. So I'll just use the message. So I'll just say error dot get message and provide the actual error as the third argument to that. Now I want that to actually be log E for error, not log I. So let's run that on the Nexus S and see what we get back. So I'm writing the logcat, so I want to look at logcat and see what's going on there. All right. So let's look at what's going on here, right? Now, with the code that's given, I should be seeing something, right, that says main activity, yada, yada. I missed something. What did I miss? My request didn't actually do anything.
You have to add it to the queue.
I have to add it to the queue, right? So if you create a request but you never add it to the queue, then nothing happens. So that's an easy thing to overlook. Oh, and I need to say request queue dot add. So add the request to the queue. That one line of code makes a huge amount of difference. And so what we should see, all right, well, what happened? So I tried to run that request. We got down to my error handler, though, instead. Okay, well, what does my error say? What is my error telling me that I need to do?
You need to add the internet permission to the
Yeah,
manifest.
the internet permission, right? So, and we've kind of talked about this already, but you know, anytime you want to get to the internet, regardless of whether it's over cellular or Wi-Fi, it doesn't matter how. If you want to have your app that can communicate with the internet, you do have to ask for that permission. One of the things to mention there too, you can either use, when you're defining these, they can be either empty tags with a closing and an ending, or you can make them as an empty tag with just a closing slash here. Either of those are equivalent. That's just an XML thing. You can either terminate it with one or the other. This is shorter, which is the one reason that we use it, because we also know that there's never going to be anything inside this tag. So that's all. You can do either one, but this one is shorter.
Just that one. There was another one we used before when we started accessing the internet. I can't remember what it is offhand.
Yeah, view network state. So yeah, that's we don't need that specifically to do this. We can still make the request with just the internet permission, which you can see it now in the log. It's showing me that timestamp being returned. The view network state enables us to look and see what the current network state is. So let me see if it's connected or not connected. So, you know, right now, because I only have that permission, I can make a request, I can access the internet, but I can't check if there's an internet connection before I try to. Does that make sense?
Yes.
And you also need that permission by the same token if you're going to enqueue a work request that needs network connections, then you also need that permission as well. So in this case, I don't technically need the access network state permission. I don't technically need that for this application, but yes, it's a good idea to go ahead and just add it, because anytime you're accessing that network, you're going to end up needing both of those. You're going to end up needing both of those in whatever app you use that communicates over the internet. So I would just go ahead and add both, whether you need it or not, as there's really no harm in asking for a permission that you don't end up using. Especially those two. So that's good. So we've got that. I might point out real quick, let's see what happens. Let's say I turn the network off and go into, let's say I go into airplane mode. So I'm in airplane mode again now. And let's see what happens. Well, okay, so when I try to do that, what exception do I get if I'm not connected to the network? So you'll notice here, I get an unknown host exception, right? Well, that's kind of weird. I'm not connected to the network, so why am I getting that error? Why am I not getting something that tells me I'm not connected?
It wasn't able to contact a DNS server to resolve the host.
Right. That's what it's telling us. It's telling us the unknown host exception tells us that it wasn't able to contact the DNS server, which means that, for one, it means that it actually did try. It actually sent that initial request to find the domain. It sent the request to the DNS. It didn't say check if there's a network connection. It just went ahead and tried it and said, well, I can't access the DNS server, so I can't go any further. So if you're not connected to the network, you're not going to get an error that says you're not connected to the network. You're going to get something like that that's tertiary and doesn't really tell you that that's what's going on. And if I'd provided this as an IP address, actually, instead of a DNS name, I would have gotten a different error, because it would have then used the IP address and gotten a different error, because it would have been, well, I can't send the request. The server won't talk back to me, kind of thing. So you can't rely on the type of exception to know that the cause is the internet's out. Does that make sense? I could still have gotten this error even with the network. So, for instance, let me go back in here and say, let's try to connect to that. Okay, that works. But what happens if I just goof up the name and I say like comms or co? If I type CO instead of com, I'm actually going to get that same error more than likely. Although here it looks like I'm getting SSL handshake instead of a missed thing. What if I try com2? Will it give me a different... There we go. So if I mess up the domain name, right, it's actually the same error as what we saw if we couldn't connect. Does everybody see that? So
yeah,
your exception's helpful, and you do get that with, the Volley error case. So you want to make sure you log that, so at least you can troubleshoot it. But it doesn't always lead you directly to like, oh, it's always this error means this, which unfortunately means I can't just say, oh, if it's an unhost exception, then tell the user to do blah, because that can have more than one cause. So that's the basic of setting those things up. So I can create the string request. I can add it to the queue. The other thing you want to do usually for cleanup processes is you want to make sure that you cancel any in-flight requests when the activity is destroyed. So for instance, in this case, I want to say if the request is not null, I can really do this in either... I can do this in either order, but I'm going to say if the request is not null, then I do want to cancel it. So we're going to say request dot cancel. So that's where that fits in. Is I would say if the activity is being destroyed, let's go ahead and cancel the request with the assumption that it could still be have not completed yet. In reality, this request is going through so quickly, right, that the cancel is actually happening after it's done, so it has no effect. But if this were to happen before, right, if this were to be canceled before it finishes, that would stop it from coming back and trying to update main activity when it's gone.
You use the word in flight. Does that just mean in progress? Is that another way of saying that?
Same thing. Right, so maybe I've sent the request to the server, but the server hasn't sent it back to me yet. Right, maybe I've asked for the data, but it hasn't sent me the data yet. So that's kind of a simple setup. We can expand this a little bit in the sense that maybe we want to show the data to show the text that comes back on the UI. And so maybe I want to go into my layout I've got a text view here already. What's the name of that? It doesn't have an ID, so let's give it an ID. And so maybe I'll just call this text view, like so. Or response text. Maybe I'll call it response text. Response text, refactor, and I will ditch the hello world text that's in there. Maybe I do want to put some placeholder in there though. So response. Okay, so there we're at. So I just got a text view named response text, and what I'm going to do is I'm going to just have it populate that in here. So private text view response text, and so response text is equal to find view by ID r.id dot response text. So grab the view. When we get the response back, I can just say here response text dot set text. Let's set it to the response, and if there's an error, maybe we'll set it to the message. So set text error dot get message. So we can provide a little bit of feedback quickly to the UI. So do that. Great. Okay, so I've got something showing up on the UI, and you'll notice in there, right, I didn't have to write an async task. It's already running it on the background for me, right? And I didn't have to implement all that code for the HTTP URL connection. Again, it's doing all that code for me. So is everybody kind of following with me where this makes the code a lot simpler? Removes a lot of that boilerplate.
Yeah.
So it's, I mean, I would say Volley's like super easy to use. It's an easy drop-in replacement for some of the stuff that we've already talked about. So let's expand this a little bit. And so let's say that I also want to maybe change the UI a little bit. So I'm going to send some data to it and have a button to initiate that request. So I'm going to update my layout a little bit. I'm going to actually remove all the connections here, remove all the constraints. And I'm going to add in two things. I'm going to add in a button, and I'm also going to add in a little edit text where I can type in a message. And so I'm going to anchor this up top here, there, and this is going to be, the width of that will go up to match constraint. I do want a little bit of margin on those sides. Same with the button. I want a little bit of margin to bring it down. So we're going to type in a message here, hit the button, and then we'll have the response pop out. So that I'm going to anchor the text view underneath the button, anchor it to left, right, bottom, and yeah, that's fine. I'm just going to have it centered on the screen. So this is going to be, this ID is going to be the message edit, and this is going to be the send button. So I'm going to change, oh, I changed the wrong one. I changed the text view. This is the response text. I'm going to change the ID of the button to send button. Send button. The text on there is going to be send. I don't want any sort of text in the field. I'm going to leave that blank initially, although maybe I will have some text in there initially. Maybe we should just say hello world is our message by default. So hello world, send, and the response. So yeah, so I type something in here, hit send, get the response. So that's kind of my starter to the UI. So I'm going to bind all that up. So in here, in here. So I want to say, let's get the edit text and the button. So I probably don't need the edit text. I probably don't need the button. So this is message edit. And so the message edit is equal to find view by ID or .id .message edit. Yeah, that's good. So I just have those two controls. And so when I send the request, I want to incorporate what's in that message in the data that I send. So I'm going to actually go back to the layout. Just like we've done before, I need to add an on-click to the button. So I'm going to say on-click. We're going to go to on-send. I'll enter to create that. So when we click on the button, we're going to call on-send. So I'm going to take the logic that I have here that's building up this request. I'm actually going to move it out of onCreate and move it down to onSend. So we won't be sending a request when the application starts. We'll be sending a request when you click on the button. So we create a new request, and then we add it to the queue. Another thing we want to be sort of careful of is there may already be a request that's running. So I may actually want to check for that. If the request is not null, if there's already a request that's running, then I'm going to cancel that previous request. So when we click the send button, we're going to cancel the previous request, build up our request, and then add it to the queue. So let's try that real quickly. I haven't obviously added in the message yet. Okay, so that works. We can see that when I hit send, that it's initiating the request. That's good. But I want to add into there an ability to grab the message that the user typed in and send it to the server so we can see it come back. So in here, I'm going to say string message is equal to message edit dot get text dot toString. So nothing new there. But what I want to do is also build up the URL. So we remember that part of what we want to do is use the URA builder to build that up. If I were to do something like this, question mark message equals message, this would work for some simple scenarios, but it wouldn't actually work for all cases. Part of the problem is that if I do this, then there's not any URL encoding happening on the values that I put in. So this can actually cause, this can actually lead to a bunch of security problems if you just leave this as is. So you can get security problems in here. You can get a lot of vulnerabilities as far as what the user can do and do things that they really shouldn't be able to do using that approach. So for instance, let's say I want to be malicious and I want to add in here and few equals bar. Now let's watch what happens. So I need to close the keyboard here. So I said and foo bar, and foo equals bar. Well, let's look at where that gets added. Okay, well, I added it to the URL. Look at the message. Well, okay, so I sent a message of blank, but I was able to inject this additional value foo and have it come back as bar. Do you see that? Because I was able to inject something into the URL. And in this case, this might not seem like a big deal. But in the real world, this is a really dangerous thing. Is everybody with me there?
Yeah.
So this is one of those things I say, never, never, never should you ever do concatenation with your URLs. It may seem like an easy fix, but it is so exploitable. And it doesn't end here because I can keep adding things to it, right? I could say, and 2 equals 3. I can effectively add all of the parameters in here that I want, and depending on what the UI, depending on what's happening on the server side, I could do potentially all sorts of things that might not be something that you want the user to do. So rather than using concatenation here, it's really important to use the URI builder instead. So instead here, I'm going to go string URL is equal to URI dot builder, and in there, actually no, it's URI dot parse. Yeah, URI dot parse, and I need to provide this URL there without anything added to it, and then we're going to do dot what was the method? Build upon. Yep. So I want to do dot build upon. And so I'm going to add the message parameter. So append query parameter. And so I'm going to specify message here. And the value is going to be the message that the user typed in. And then finally, I just need to call toString to turn that back into a string. So I'm going to provide that URL here. And so by doing it there, things should get URL encoded. Things should be safe. Hello world. That goes through fine still. And let me try what I had done previously, and foo equals bar. Send. And there it goes through properly. You see how it comes back as and foo bar, right? It didn't let me manipulate or inject code into my URL. It still treated it as data because it was properly URL encoded. Does that make sense? Is everybody understanding the reason for that?
Say that last part again about why. What?
So this did not allow me to inject additional query parameters, right? Because I'm not doing this as a string in concatenation, the actual URL that this builds out is a different URL. So let me just log it real quick so we can see what the URL is that got sent. So log I, log tag, and URL. So I'm going to log that URL. And so, and foo equals bar. There. So look at the URL that's here, right? So the ampersand got replaced with %26. The equals got replaced by %3d. So that's one of the things that your URI builder does out of the box that you don't get from string concatenation. Does that answer your question, Paul?
Yeah, I understand what it does.
So that's really, really important from a security perspective. That's things like this these seemingly little things are actually the things that most of the times hackers end up exploiting. Those are the little things that more often than not are part of the entryway for people doing things that you don't want them to do. So that may seem like a small thing. That may seem like, hey, well, that's, now I have to deal with, what about exceptions that might throw? Like, well, you have to deal with that. So that's that. One let's see. So the next thing I might want to do is maybe I want to do something a little bit more advanced with the response that comes back. So right now I'm doing a string request. I'm strictly looking at, let's show the response as a string. So what happens if I want to read it, right? I want to read it as an actual JSON object, right? What kind of request should I make here? What kind of request?
If you're trying to read it as a JSON object, it'd be just a JSON object request.
Okay, that's correct. So let's change this to a JSON object request. Now there is a little bit of gotcha. As soon as I change that over to JSON object request, there's some inconsistencies in the signatures. So you see immediately that this one gets a red underline. Because there's not a constructor for JSON object request that takes 4 parameters. So you see it's saying it expected JSON object request, but found something else. Does everybody see that? It's giving me incompatible types.
You have to have the null in there, right?
I do need to introduce a null. So that null is for data. If I wanted to send an object to the server, that's where I would put it. Now, why? Oh, it also needs to change the type. So the type of the response now is a JSON object. So we get a JSON object back, and I need to put a null there. So let's say I want to read some of those values. So we know that we're getting a timestamp. We know we're getting a message. So I can try to read those things. So let's say in here, I'm going to say string message response message is equal to response dot get. So I'm going to say let's get string, and the name of that is going to be message. And usually, more than often, you want to call a different method because you want to say, well, that may or may not be there. So optional string, and say if that's not there, then we'll just fall back to empty string. And we want the timestamp as well. So string response timestamp is equal to response dot optional string, and so that would be timestamp. So if those things are there, grab it. Otherwise, we're going to have empty string. Okay, so if those things are there, or maybe I used null as my fallback. Yeah, I will use null as my fallback.
You got a red error there on 74.
I'll just leave it as empty string. Yeah. Well, because I haven't updated that yet. So I need to say, well, what am I going to put into the text field now? So when it succeeds, when it goes through, I want to spit that out in a different format. So maybe I'm going to say string dot format, and we'll say the message oh, I need that to be a string. So message colon space %s /n timestamp space %s. And so this will be in a little bit more reader-friendly format. If I want to get more fancy, I would probably want to parse the timestamp, but I'm not going to do that here. This is response message and response timestamp. And so if I get that, I should send, there we go. So I've I pulled out the message and I pulled out the timestamp. Cool. So I'm not just showing the raw JSON that came back. So everybody follow tracking with that?
Yeah, you're gonna upload this to GitHub later.
Yeah, I can throw this. I can throw this.
All right, I got a few bugs. I'm not sure where they're at, but
I can throw
I'll sort it out.
Project up. Again, this is not for a grade. We're just kind of walking through to give you an example of how this works. So, does that make sense? I hope you can. Can you see the value where this is a much smaller program, and will lead to a lot less code than what we've done previously. And so that's why I say that, the big benefit of Volley is just in reducing the amount of code that you have to write, in reducing your boilerplate code. Because for this example, this is not significantly faster than what we've done before. You won't see a huge benefit in performance, especially since it's so quick. But it does provide a huge benefit even for something simple as like this, in terms of being able to write the code in a more readable and just easier fashion. So I'm going to commit and push this up.
This is the same repo you've always been using, right?
I think I actually put it into the wrong folder. So let me close Android Studio because I did put it into the wrong repo. New folder. Okay, it's in the same one. It's in Android Labs completed. It's under Volley examples now.
Okay.
So, yep, you can pull that down, play around with it. And tomorrow we'll just need to talk about how to use use this together with Work Manager and such.
Are we gonna have another? Go ahead, Paul.
Okay, it's just a code along day. Tomorrow we'll just watch you do it and ask questions, and then we got to sort it out on the lab.
Yeah.
Right?
Yeah. What were you going to say, Corey?
That's basically what I was going to ask, if tomorrow was going to be a code along day.
Yeah, that'll be the case. I'll try to keep it short, so that you have adequate time for labs. But yeah, so that's what we'll do. We'll just kind of go through a quick example there with the Work Manager and such. How does that fit in? And I need to talk about the JSON request. How do we bring that into? So JSON request and the Work Manager stuff. Cool. Any questions about the material?
This is pretty easy. It'll be interesting to see how it works with the Work Manager.
Mm-hmm.
I'm expecting that'll be a lot, because I kind of thought of the Volley doing some of that stuff, but it doesn't.
Mm-hmm. Yeah, it doesn't, and that's the kind of that's the gotcha, is that is that it doesn't really do any of the stuff that Work Manager does. So I will say, you know, I've got a working example. You can read it on Perusal. If you go up there and look under the assignments using Volley with Work Manager, that's basically what we'll be talking about tomorrow. So there's a code example in there of how I got it working. I will say I had to kind of patch through a few different things to make it happen, because suffice to say the documentation is not great in the areas where we have to touch, and so we'll have to talk about a few things that we haven't done with workers yet. So in the end, it's not a whole lot of code. It's not a whole lot of code, but there is some boilerplate in there, and there are some things that we have to do differently because of, you know, how Volley operates to get the two to play nicely together. Okay. So if there's no questions, you guys can head off, and I will catch up with you tomorrow so we can finish up the material on this.
All right, thanks.
See ya.
Yep.